So Renuka, to check, like, is my screen properly viewable and I am audible?
Yes, sir.
Okay, thank you very much. So students, good evening, and we welcome you all to the 16th session of our ongoing EV course. And this is the extension of the electrical motors that we studied or we covered in our last session on Wednesday. So we would be going further deep into electrical motors, the concepts and other things. In last session, we were very much focused upon their use into the EVs. Now we will be also learning some general concepts about the motor in this course, in this session. Sorry. So to start with, we'll learn about the basic working of electrical motors, then laws related to electrical motor, basic components of an electrical motor, combustion engine versus electrical motor, then reading of electrical motor specifications, motor protection and its maintenance, overload protection, proper installation, decreased friction, guidelines for storing electrical motors, and safety. These are the few subheadings under which today's sessions would be focused on. So as we discussed on that day, that motors being the prime moving agent, or you could say the entire EVs, if you talk about, are one of the primary components of the electrical vehicles, whether two-wheelers, three-wheelers, or four-wheelers. So the controller or the battery, which are other primary components. So controllers and other safety devices are focused on running and controlling of the motor, and battery is there to provide power to the motor. So at the end of the day, the movement that the EV vehicle receives is through the motor only. So motor is a very critical component. So to brush up on that day, we discussed some few kind of motors that are used in the electrical two-wheelers and four-wheelers. There we discussed focused on hub motors. What are the construction of a hub motors, what are the parts of a hub motor, where magnets are placed, where Hall sensor is placed, what is the use of the Hall sensor. So all those topics we covered in the last session. Today we will be discussing some few upon the few points upon the some laws and basic working of electrical motors. So basic working of electrical motors, everyone knows that the basic laws governing the electrical motors. So we know that mainly being the magnetic field induced due to the current flowing into the field windings, and if we place a conductor in between them, then it shows rotation, or it tries to align to a certain direction. So there is a movement. So this movement can be made continuously through either through changing the direction of the current, or through proper winding placements it could be done. So that is the basic principle on which the motor are based on the basic principle of magnetism. So an electrical current is current in a magnetic field will experience a force. If we pass an electrical current through a conductor, then if there are two permanent magnets placed, so then it will experience a force due to the magnetic field. That is the basic concept of a motor. So the pair of forces creates a turning influence or torque to rotate the coil. So this forces, so the rotational effect that it causes, the forces which makes the rotor in the motor move, or any conductor placed between the magnets move, that induces a torque. The movement, the rotating motion is called the torque. So this is as per the Lorentz law. Okay, so if the current carrying wire is bent in a loop, then the two sides of the loop which are at right angles to the magnetic field will experience forces in opposite directions. Okay, so practical motors have several loops on an armature to provide a more uniform torque, and the magnetic field is produced by the electromagnet arrangement called the field coils. So basic concept remains the same. So construction and the motor was invented principle only. So to make the motion in a motor uniform and continuously, we have made the windings more particular, appropriate. We have changed the number of the turns and the placement of the windings. Depending upon then, we have worked on the permutations and combinations to come up with motors which we are using in the modern processes that we are using. So it can be a DC motor or an AC motor. So the concepts remains the same. And to make it more effectively, we have been making changes on the placement, on the windings, and the material that we are using in the magnets accordingly to make the motors more efficient and their usability, to extend the usability of their in the day-to-day processes. So laws related to electrical motor, Faraday's law of induction. So according to Faraday's law of induction, Faraday's law of induction is the fundamental law on which electrical motors operates. So Faraday's law generally states that in a closed loop of wire, a change in the magnetic environment of the coil causes a voltage or EMF to be induced in the coil. The induced EMF equals the negative rate of change of the magnetic flux times the number of turns in the coil. So this is the basic Faraday's law. So where if you talk in terms of formula, if you talk, then if E is the EMF, so it is negative of n, the number of the turns, then change in the flux divided by the change in the time. Delta n delta phi upon delta t, where E is the EMF, n is the number of turns in the coil, phi is the magnetic flux, normally calculated in Weber or WB, and t is the time. So this is the basic formula by which the Faraday's law of induction is governed. Other laws which also are utilized in the construction of the motors are Lenz's law. So Lenz's law explains why the EMF generated according to Faraday's law is negative. So Faraday has given a law law of induction, and according to which the EMF that would be generated in the coil would be in the negative, it would be negative. So Lenz's law further explains why it is negative. So Lenz's law explains why the EMF generated according to Faraday's law is negative. States the polarity of the induced EMF is such that it generates a current whose magnetic field is in a direction that opposes the change that produced it. Okay, so it's like the very cause that has affected the induction, it would oppose that, due to which the product that we get, or the EMF that we get is normally in the marked as negative or in the opposite direction. Fleming's left hand rule, if we talk about, so the direction of the rotation of this motion is given by Fleming's left hand rule. So you could see in the left hand, use our the thumb, and the two fingers, then middle finger and the index finger if we use. So we would see that the direction of rotation of this motor is given by Fleming's left hand rule, which states that if the index finger, middle finger, and thumb of your left hand are extended mutually perpendicular to each other, and if the index finger represents direction of magnetic field, middle finger indicates the direction of current, then the thumb represents direction of which force is experienced by the shaft of the DC motor. So in DC motors, this Fleming's left hand rule can be used to find out the direction of the field, in which direction the field is induced, okay, or the force is being experienced by the shaft in the DC motor. So now talking about the basic components of an electrical motor. So if we deassemble an electrical motor in any kind of an electrical motor, so we would find that it would contains primarily these many parts. So rotor would be there, stator would be there, windings would be there, commutator would be there, ferromagnetic iron core would be there, armature, magnets, and sensors would be there. So rotor, as we know, the moving part is normally the of a motor is called the rotor, or and a stator, that part which remains stationary, which doesn't move, okay, that is the stator, okay. And windings, if we talk about, the windings are done which would be to induce electromagnetic field. So there could be different, the windings could be different, they could be found only on the stator, they could be found. There could be winding on the rotor also, depending upon the type of the motor the windings placement could be different. And the commutator, if we talk about commutator is normally found in the DC motor, the brushed DC motors only we find the commutator. So main function of the commutator is to continuously change the direction of the current in the winding, so that the continuous motion of the motor is maintained, and so that the permanent magnet field and the field induced in the stator windings does not tend to become parallel, or doesn't tend to become in a single direction, so that the rotation of the motor ceases. So this always maintains that it always makes sure that one coil is charged at one instant, so that this repulsion continues, and we could see a continuous motion of the motor. Ferromagnetic iron core, so iron core would be there, then armature would be there, magnets would be there, permanent magnets would be there. The magnets could be of different type, they could be depending upon the motor, they could be different, and they could be rare earth magnets also, and or they could be permanent ferrite magnets also, depending upon the type of the motor. Then sensors, as we spoke about, the sensor mostly the electronic controlling, where it is like commutator, electronically where commutation is happening, or if the motor control is such that we are using some electronic controllers or electronic control units if we are using. So for that, for coordination, there would be sensors in the motor placed. The Hall effect sensor that we saw in the last session. So components of motor, if we talk about the windings, the motor winding also consists of loops of wire, two sets, usually one thicker than the other, to cause a phase shift in the voltage being supplied. This is where the AC or DC current is supplied, which produces a magnetic field. So normally this, if we talk about the windings, they are like in multiple turns, they are placed in such a way that they forms a, then when current is passed through them, DC or AC current is passed through them, they start acting as electromagnets. Okay, so the direction of the current can be changed from time to time, and the intensity of the current can be changed, so that at the same time the intensity of the magnetic field induced also changes, and this way the input that it would be taking, the current input that it would be taking would be dependent upon the load. So as the load will be changing, so will be this strength of the strength of the induced magnetic field has to be changed. So accordingly it would be varying, the input current, it would be varying. Okay, and commutator, if you talk about, it is a slip ring made out of copper attached to the armature. It reverses the direction of the current to keep generating torque. It can also be an electronic circuit like a Hall sensor or BLDC motor. So if it is brushed DC motor, normally commutator is there, but in modern BLDC motors we don't find commutator. In place of it, we use Hall effect sensors we use. So commutator, if you talk about, they are nothing but they are slotted, their copper slip rings are attached on the extended shaft only, and with the help of the carbon brushes, they get connected, and so that from time to time, from instant to instant, the direction of the current will be changed. Rotor, if you talk about, as we said that yes, rotor, the rotating part of the motor would be called as the rotor. Okay, so rotor could be of different forms. There could be, the rotors could be like in some motors, the rotors could be like plain rotating part where magnets would be placed. In some kind of motors, the rotors might not contain magnets, but they might, the rotor also might be might have windings on this. So slip ring induction motors that we see, they have winding on the rotor also. So depending upon the kind of the motor, there the rotors are of different forms. So if the rotating, it is a rotating part, it is attached to the shaft and is required for the torque production of the vehicle. In a squirrel cage rotor of an induction motor, the current flow in the rotor is not caused by any direct connection of the conductor, so a voltage source of the conductors or voltage, but rather the influence of the rotor conductor cutting across the lines of flux produced by the stator magnetic field. So if we talk about the squirrel cage rotor, if we talk about the it doesn't contain any magnets, it doesn't contain, so field would be generated by the by the change in the magnetic flux. Okay. So because of that, there would be an induced magnetic field in the rotor. And if you talk about slip ring rotor also we have shown. So that you could see there is an extended shaft over which these copper rings are mounted, which would be which would be connected with the help of the carbon brushes. They would be connected. Stator, if we talk about the stationary part of the motor, is called the stator, and normally the stator has it's slotted, properly slotted, and so that the windings are placed into this. So the stator is the stationary part of the motor with windings attached to it. This is where the RMF is generated to produce rotating magnetic field. In the stator of a three-phase AC motor, all that need to be done is wind the stator coils properly and connect the power supply leads correctly. So if we talk about in three-phase induction motor, the windings will be placed accordingly. Okay, they would be placed accordingly so that when connected with the source, the rotating magnetic field would flow through these windings placed in proper ratio. There would be like coil ratio, proper coil ratio would be maintained. There would be the number of the slots would be fixed, and they would be placed in such a way that and we know that how many number of coils has to be made. So the number of coils would be made. They would be placed in the properly. They would be placed in the slots, and then they would be supplied from the external supply. They would be placed. If you see this picture of this motor, there you could see a capacitor over it. So the presence of the capacitor shows that the motor is a single phase motor. So normally single phase motors are induction motors are not self-starting. So we use capacitor to make them self-starting. The concept that we normally see in our electrical appliances, home electrical appliances like fans and other appliances, where we are using normally where we are using single phase induction motor where we are using. So the armature is a device that carries alternating current even on DC machines via the commutator. It consists of windings, a commutator, and iron core, etc. The armature windings conduct AC even on DC machines. Due to the commutator action, which periodically reverses current direction, or due to electronic commutation and is brushless DC motors. The armature can be on either of the rotor or the stator, depending on the type of electrical machine. So normally the use of the armature is it consists of windings and a commutator and iron core, etc. The armature windings conduct AC even on DC machines due to the commutator action. So which periodically reverses current direction. So it is a combination of our commutator. It's connected with the commutator. So part of the rotor only. And if it is a like a brushless DC motor, it is, then it would be accompanied with the it would be the armature would this commutator would be normally replaced through a Hall effect sensors. It would be replaced through a Hall effect sensor. So the it would be part of the of our router only, and there would be this would be either will be combined with a commutator if you talk about brushed DC motor, and with Hall effect sensors if we talk about BLDC motor. So magnets are used to generate rotation by providing magnetic field inside the magnet. They can either be a permanent magnet or electromagnet. So normally we use magnetic field if we are talking about BLDC motor or any DC permanent magnet DC motor. So they would have permanent magnets. And to have electrical vehicles, we spoke about that we need a powerful motor in a small space. We need a powerful motor. So for that, the permanent magnets also has to be very strong. So for that, we normally use the rare earth magnets we use, which are generally very powerful with very high power density they have. So that helps us to make a very powerful motor in a very less space. Okay, so that say if we are constructing a 1 kilowatt motor, if it would have been normal ferrite magnets, the shape would be 4 times larger than what we see today, the 10-inch or the 12-inch diameter that we see. So it would be say 4 times bigger than that, because but all thanks to these rare earth magnets, we could do it in a smaller space, and with more powerful motor can be constructed in a smaller space. The only constraint that we have is that these magnets are not easily available. They are not in abundance. They are their production is restricted only to few countries. So that is a negative point attached with these motors. So but in case of induction motor, if you talk about, they don't use permanent magnets, but the electromagnets. So they use the electromagnet, so they are powered by the external source, which and there are windings placed on the stator, which converts into electromagnets for the rotation of the rotor. So here we are comparing combustion engine versus electrical motor. So what advantage do we get if we replace the normal IC vehicles, if we replace with electrical motors? What are the advantages that we get? So combustion engine, if we talk about 1 to 3 kilowatt per kg of combustion engine, and 3 to 10 kilowatt per kg. So you could see that in 1 kg, if we construct a combustion engine, the best of the combustion engine, then that would can only give a power of 1 to 3 kilowatt. Whereas if we talk about electrical motor, in the same space, we can have an electrical motor of 3 to 10 kilowatt power. So this is 3x more powerful motor can be constructed in with like similar volume or weight. If we talk about, so in similar volume, we could have a 3 times more 3 times powerful motor we can have. So that saves a lot of space for us. So 0.4 kilowatt per liter is the efficiency of the combustion engine, whereas 13.6 kilowatt per hour per kilowatt per liter is the efficiency of the electrical motor. So volume wise also, if we talk about, the electrical motor would be 40 times smaller for the same amount of the power. 5 to 30% is the efficiency of the combustion engine, whereas if you talk about the electrical motor, the efficiency can go as high as 93 to 96% also. So that is again 3 to 20% more efficiency. And with the time, if we are properly maintaining the motor, the efficiency doesn't degrade so drastically, but it happens in the case of the combustion engine. In the combustion engine, there are many moving parts. And if you talk about the electrical motors, there is only one moving part, that is the rotor is only the moving part. And so the motors are more maintenance free in comparison to the combustion engines. Rating of electrical motor specification. So if you see, every motor is rated, they have a name, they have a identification plate over them, where all the parameters of the motor would be mentioned, as how much kilowatt the motor is, at what voltage it is working, what is the RPM of the motor, or even there would be frame size would be there, then what are the insulation levels, everything would be mentioned on the motor. So normally, if you talk about like industrial motors also, they have a particular plate they have, where all the information related to the motor, from its frame size, voltage level, current rating at a particular level, everything would be mentioned on the plate. So the nameplate provides information that assist a person selecting the proper motor for the job, making installation in energizing the motor with proper voltage. Okay, so that helps us to identify proper identification of the motor. So we will discuss the specification of this nameplate. So if we see, it's a typical nameplate of an industrial motor, not an EV, but an industrial motor. So universal electrical motors indicate standard replacement motor. So thermally protected motor equipped with devices to connect the current flow becomes too hot. Motor equipped with devices to disconnect the current flow becomes too hot. So if the temperature exceeds from a certain level, the motor would disconnect, or it would trip to disconnect the shut down the process. So these serial number that is given, it is manufacturer serial number, it is unique for every motor, so that we can trace it. if there is an issues, we can go to the factory and like backtrace like in what condition it was manufactured and why this fault has occurred, or then that entire lot can be checked if only the particular motor was containing this fault or the entire lot has some issues. Then model number is there, so this could be specific to a large number of the entire lot. It could be can be it might not be unique, but it could be of a certain lot when it has been manufactured. It is coded according to the manufacturing date and in like which unit it has been manufactured and all those. So stock number, then stock number is there of the manufacturer, then at the voltage range is there in which it could function. So 208 to 230 safe levels of voltage where it could function. Frequency designed for, then amperes, how much ampere does it draw at full load capacity, then RMS RPM, sorry, RPM, the RPM that it at which it would be rotating. So from the RPM we can generally find out that how many poles the motor contains. So it could be normally we can easily find out like how many poles are there for the motor by the rated RPM. PH1, so motor runs on single phase. So phase is single or three, depending upon that. This we could find it out through this code. And motor is equipped with a continuous operation run capacitor rated at 5 microfarad and 370 volt AC. So as we see that this is a single phase motor, so we would be using capacitor to run this motor. So this would be the basic identification of the capacitor that is being installed for this motor. So then insulation class would be there. So as we know that there are separate different insulation classes are there for the motor. So A, B, C, D, E, F, in different to take care of different temperature, the insulation class would be there. So that has to be properly mentioned on the plate of the motor also. So, and ambient temperature to which it could withstand, that is also mentioned on the motor. The rating of the motor, how many HP it is designed for. So continuously duty. So if continuously is mentioned, we can run it continuously, like without any break. It could be run. Definitely when we have to take it for maintenance after a few days to check the bearing quality and to properly grease it. But otherwise, it is it can be run on a continuous basis. Motor will pull rated load under rated condition and not overheat. So if mentioned continuous, so if it is the loading is as per the mentioned conditions, then it would be continuously running and will not overheat. But from timely, we have to take it for timely overhauling to check the bearing condition and to grease it or properly grease it, so that we could run it for a longer, so that reliability is higher in a long run. AO, air over ventilation, is used to cool this motor. So if AO, so forced, there would be a fan installed. So that would be used for flowing air across the motor for its cooling to maintain the proper temperature. ROT, reverse, indicates direction of rotation of the shaft. So in what direction the rotor is rotating, that it would be mentioning. So BRG SLV motor has sleeve bearings. Okay, so this normally defines the kind of the bearings that have been used in. So all these specifications are very necessary when we are purchasing a motor for a particular process. Normally in the industry, and maybe the specification plate would be different when we consider EVs, but this was a typical plate of a normal motor used in the industries. Motor protection and maintenance. So as we see, when motor is installed for a particular processes, there might be because there might be some processes where we need continuously has to run. Okay, or even minor fluctuation can cause a huge loss in the production. So we have to have motors properly maintained from time to time, and they have to be properly protected. Otherwise, if breakdown occurs, then they could cause a huge loss. So either we maintain a standby motor, we maintain, and if the standby does, if we are not allowed by finances to have a standby motor, then what we have to do is when we are installing the motor, we have to do it so properly that the protection is taken care of, and from time to time we have to take the entire machine for shutdown. So plant shutdown could be there, so that we can keep on analyzing it, and if any problem is there, so that could timely be taken care of. So preventive maintenance could be should be planned from time to time. Need to have a schedule, so that we keep the production team also informed that like from this time to this time we would be taking it for schedule maintenance. So what schedule maintenance help us to do is it helps us to protect the motor, because in some cases some motors are so sophisticated, so that if it breaks down, or if they develop a bigger snag, say if the windings have burnt out, and if a motor is say 100 HP or a 120 HP motor, is that huge motor. So if even if it goes for rewinding, and a test would be there, everything would be there, and then it would be coming back, so it would be taking a very long time, 15-20 days it would take. So instead of that, we should be properly maintaining it, so that that kind of condition doesn't occur. Overload protection. So as we know that the input current will be direct in any kind of the motor will be directly dependent upon the load it is driving. So because main use of the motor is to drive a load. So if we are say driving any with connected to the shaft, and if we are driving any load, say for elevator, if it is connected to an elevator, or if it is connected to any process, we should take care that it is not overloaded at any condition, because normally motors are rated to overload to a certain percentage. Okay, say 10-20% only overload can be done, but that also not continuously. If that keeps on happening on continuous basis, the problem arises is that it draws more current to run the load on at the same velocity. It takes in more current, and which with time what problem that creates is that will affect the windings, okay, of the motor. So they start becoming weak, and that could be that they could the insulation could heat up, and condition could occur where the insulation goes away, and there could be short circuit, and we can lose the winding of the motor. So every time it has to be taken care of that we don't overload the motor. We keep on checking the amperage drawn by the motor. So if they are under proper levels, then only we should continue with the process. At times what happens is, even because of problems in the bearings or any internal issues also, the motor starts taking more current than the rated one. So at that time we have to overhaul the motor. In a particular time we have to overhaul it, so that normally the burning of the windings or other major fault doesn't occur, or doesn't affect the process and the motor. So motor size is too small for the job. Motor size is too small for the job. So say if our load is higher and we have used a small motor, so in that case there would be an effect on the motor. So sizing of the motor is very important. We should take care of like what process we have to run. So accordingly we should size, and we should select the motor. Improper winding and low voltage. So even if the winding of the motor is not proper, then also it affects the motor. And if say the voltage, we have a fluctuating voltage, the voltage input is lower than the rated voltage, then also it would be drawing more current. So at the end of the day, like over current, if it is drawing, then it would be causing a lot of issues. So that could be due to because of selecting a lower motor size, or low voltage, or improper wiring, or improper lubrication also. As we said that if there is an issue with the bearings, then also it could cause problems. So clogging due to overload. So if even the process that we are trying to run, if there are issues on that part also, say clogging, or if that is also not properly lubricated, then also there would be an effect on the motor also. then also there would be an effect on the motor. So all these things should be taken care of properly taken when we are installing the motor, so that the motor life is elongated and the process reliability is maintained. Protection, proper fusing of the motor circuit, manual reset, switch control, and special motor starter. So motor should not be directly connected. We should have a proper motor starter so that they could be initially when they need a high starting torque, that could be given, and then the switching could be in the next mode, that could be when it attains some speed, that could be done in the next mode. So accordingly we should have a proper starters for kind of depending upon the motor. If we have to run some process at a particular RPM, then we should be installing proper where frequency drives we should be installing, and there should be proper like cutoff switches would be there, so that if any abnormal condition arises, the tripping could take care of the tripping could occur, and that could take care of the protection of the motor. So this way we can ensure the safety of the motor. So proper installation, minimum amount of vibration, proper alignment, misalignment causes belt and bearing wear, factors in overloading motor. Protection, lighting all mounting bolts, check bearing for slack and disengage vibration motor from machine. So normally what happens is when we are installing the motor, it would be connected, it would be used to run some machine, or its prime mover would be shaft would be connected to some prime mover. So at that time, it should be properly ensured that the alignment is not misaligned. Even a small issue here and there, and if we are having a high rotating motion process, if we are having, so that will again this misalignment will be this small fault, or this small misalignment that would be keep on multiplying with the span of the time, and it would become big enough to either cause damage to the motor or to the machine that it is moving, or it could even hamper the operator who are working on this. So at every point of time when we are installing this, at that time only it should be ensured that we have installed it properly, so that there is no misalignment, because of which misalignment what happens is the effect would be coming on the on the bearings, the effect would be coming on, and if there is a wear and tear of the bearings, then it would be affecting the rotor also in the long run. So bearings, if we talk about in smaller motor, so there is, it's not a big issue, like bearings are not a big issue. But if you talk about alternators, bigger machines which runs on 3000 RPM, and so the bearings is a bearing protection is again bearing protection, bearing cooling is again a separate process in the motor and in the generator. So we have to take care of, we have to proper protection has to be ensured. So that could be only ensured when we have a proper alignment. So say if we have a alternator connected to the a two-pole alternator connected with the if with any turbine, and if it is not properly aligned, then the wear and tear would be happening so fast that we could not imagine, and that could hamper in the shutdown of the plant and causing a huge loss to the production unit. So alignment has to be always there. We should be checking on the belts through which it is like driving the machine, and proper setting of the pulleys, even if when we are taking it for overhauling and all those processes, then we are ensuring that the fitment is proper when it has been reinstalled there. So protection, tightening all mounting bolts should be tightened when we are reinstalling the motor. Then check bearing for slacks. There are no slacks in the bearing, they are properly fitted tight, and disengage vibrating motor from machine. So if there is any vibration happening in the motor, that should be disengaged. That should be the root cause of the vibration should be checked, and then again it should be installed. Decrease friction, prevents excessive bearing wear and overloading. Manufacturer recommendation for lubricant intervals should be followed. Use high quality lubricant. Alignment of motor drive and equipment should be true. So we should be from time to time, whenever it has been instructed as per the manufacturer, we should be lubricating the bearings, we should be properly lubricating, we should be overhauling the motor. If say if it has been mentioned that every 6 months for continuous running motor we have to change the bearing, that should also be done. So by ensuring all these things, we can have a more reliability from the motor and can use the motor for a much longer duration. So pay strict attention to manufacturers' lubrication instructions. So lubrication instructions and overhauling, time to time overhauling is must for better utilization and better running of the motors. Protection from dust. So accumulation of dust in and on motor acts as insulation and may cause excessive heating of the motor. So what happens is, as we said, that motors are all season components, so they could be installed anywhere depending upon the process. There could be high the process could be so that there is like heavy heat generated near to that, or there could be process where a lot of dust is being generated. So we should ensure that from time to time we are overhauling the motor and we are protecting it so that these dust doesn't accumulate on the motor, because that would again prevent the heat dissipation of the motor and can and then can also result in overheating of the motor, and again the performance of the motor can be disturbed. Protect from moisture. Moisture is a conductor of electricity. A wet motor should be directly thoroughly before it is used. So every time from time to time timely maintenance, what we should be doing is we should be checking for the moisture. Okay, so because if moisture accumulation occurs in the starter, or in case of motors, if motors are say continuously running, then the case of the moisture doesn't arises, because it develops heat when it is running. But what happens is, if a motor is left for a very long time unattended, or it is not running for a long time, so what happens is there would be an accumulation of the moisture. So when we are again starting a motor after a very long time, then we should be making it, we should assure that the motor doesn't contains a moisture in it. Okay? Mostly during the rainy season, where when then water could seep into it or could develop moisture. So at that time, either we should be opening the motor, checking for the moisture, and we should take the steps so that we could evaporate this moisture by baking the windings and all those processes. We can use it so that this moisture accumulation can be reduced, or it can be removed. Guidelines for storing electrical motors. So store it clean and dry indoors if possible. Avoid heat, humidity, and vibration. Store in position for the intended use, horizontal for horizontal and vertical for vertical. Always remember to pack the bearing cavities with grease to protection from moisture. Apply rust preventive coating to the shaft and other exposed machine surfaces. So this should be timely done so that we could elongate the life of the motor. It is recommended to use shafts at regular intervals monthly. So always it should be recommended that we should not leave the motor for a very long time. We should not leave it unattended. Safety, if we talk about safety precautions for assembling and deassembling of motor, always disconnect the motor's electrical power source before making any adjustments. So when we are deassembling the motor, when we are attending the motor for say overhauling or any maintenance issue, so we should always disconnect the motor's electrical power source before making any adjustments. We should disconnect from the source and then only we should attend the motors. Discharge capacitor to prevent electrical short. So capacitor should be properly discharged, because we know that capacitor stores charge in it, so it should be properly discharged so that we don't experience a shock. Beware of moving parts. So when we are attending a moving motor, we should always see that the belt portion and other portion, they have a proper they are properly covered. Okay, because what happens is, there is no proper guard on them, then they could cause, there could be an issue, or like if we are crossing across the motor and if we have loose cloths, then they could that could cause that could be a cause of accidents. So beware of, we should take care of the moving parts. We should be very careful when we are moving across the motors. necessary electrical repair should be made by a qualified electrician only. So we should take care that only qualified electricians only we are using, and remove and replace any safety guards. So safety guards are there, so they should be properly installed and properly be installed and removed, so that they could prevent a lot of accidents. They could prevent if we are using the safeguards over the belts and other moving parts of the motor. So thank you everyone. Like today we discussed mostly on the laws governing the motors, and mostly we discussed upon the industrial motors, how they uh, are installed, how they are used, what precautions we should be taking care of, how should be maintaining the motors, and like switching and everything we have discussed about. Definitely like EV part was less into this, but it could be definitely, it could be reciprocated, or it could be the same thing could be done with the EV motors also. Same thing applies to the EV motors also. But since like we will also be when we talk about the EVs also, they would be also be manufactured in some or the other plant where this would be very useful. That is why we took this additional session we took about the motors, because in the very first session we spoke, what we said was that motors are the backbone. Okay, we need motors to drive any sort of process in any manufacturing industry you talk about, in any appliances you talk about, you would find a motor in one or the other format. So if now anyone has any query, I'll take 5 minutes gap if it is okay. So Renuka, like, I will take a 5 minutes gap and then we can start with the query session if it's okay.
Okay, sir.
So students, you can be ready with your queries. Like I'll take 5 minutes and then we'll start with the query session. Yes, hello everyone. So
Yes, sir.
before start taking the query session, like last session, I think Uday has asked to explain about the uh, the reluctance motor. He has asked to explain. So I'll just take 5 minutes to explain that. So switch reluctance motor he has asked about. Students now mostly what we are seeing that in EVs we are using more and more BLDC motors we are using. Either they are the mid-drive motors or they are the hub motors. But in both these kind of motors, or we are using the permanent magnet synchronous motors there we are using. So in all kind of motors, what we are seeing is there is a use of rare earth magnets are being used. Okay, mostly because we want to have like much more powerful magnets in a smaller volume or in a smaller area. So we are using mostly the rare earth magnets we are using, which are again, as we have spoken from time to time, that their dependence which increases our dependence on other countries, because the deposits of these rare earth used for making these magnets is restricted to only few countries. But if you talk about switch reluctance motor, if you talk about in these kind of motors, we don't have like magnets on the rotor. So on the stator, we have windings as we have in normal magnets. We have there is again sensors are there to switch the current in the windings, but we don't have permanent magnets here. So what happens is the rotor itself is made up of steel and it is slotted. So because of the induced magnetic field, due to the induced magnetic field in the field windings, there is a EMF generated, and due to which there is a rotation. Okay. Okay. So in this case, the best benefit to us is that they don't use the permanent magnets. They don't use. Okay. But why their use is not that popular in electrical vehicles? First of all, it is because of they are the best suited when we have a vehicle, we have a use from 10 to 15 kilowatt and higher. If we have any load, then only their use is more proper. So for smaller vehicles, designing these kind of motors is a bit of an issue. So we are normally still we are getting we are forced to use BLDC motors only. Then since this air gap has to be very small, otherwise so this their construction becomes a bit complicated. So if this air gap is higher than the restricted, so there would be a higher losses would be there. So due to all these restrictions, the still the use of switch reluctance motor is limited. But yes, research is being done because they could be a game changer for the replacement of the BLDC motors, and we can't rely much on the BLDC motor on a longer term because these magnets is an issue. And if even we have a manufacturing facility in house, even if we develop indigenous motor, then also we would be depending on a large scale on other countries for supply of these rare earth magnets. So yes, anyone now they can ask their query. If anyone has any query, he can either raise his hand or he can put in the chat box. So first, I have received a query in the chat box. Botha Ramesh has used industrial motors are used in vehicles. So Ramesh, to be very precise, like these all comes under the category of industrial motor only, EV motors also. But normally, since in industry, if you see the motors, you would be using normally the induction motors are used, and they have a definite shape and size they have. Okay, they have that what we call the frame size of a motor. So they have a different size. But if we talk about EVs, we have to customize the motors depending on which depends normally on the type of the vehicle that we are using in. and say whether it is a hub motor or a mid-drive motor. So all are industrial motors, but definitely their uses in different places. In industries mostly we see induction motor, and in vehicles we normally use the BLDC motors. The DC motors in industries is like the use is again very restricted. Yes, Uday has raised his hand. So yes, Uday, you can go ahead with your question. And Ramesh, if you have like if you have further query, you can again put in the chat box or you can raise your hand.
Sir, good evening, sir.
Yeah, Uday, good evening.
Sir, what is the best motor to use a commercial buses or commercial trucks?
That would be definitely that would be I would say induction motor is better, and even we could use this switch reluctance motor can be used, because if we have to drive a load more than 20 kilowatt, then reluctance motors can be used. But induction motors are since better with their speed control, so induction motors can be used, and research is being done so that these more application and this use of switch reluctance motor can be made. Okay, because in this case what happens is we don't have to use any inverter we don't have to use, so one component can be reduced in that case.
Sir, can we use DC series motor?
DC
Series motor, because the initial torque will be high in DC series motor. It may use for a commercial vehicle.
Yeah, commercial vehicle we can use, but again DC motors we want to restrict their use, because what happens is again we have to have like that sort of magnets also we have to have. Okay. So what happens is every magnet has a particular power intensity they have. Okay, and say if when we are using for a bigger vehicles, they're getting a magnet in that bigger format would be there. Then making a motor would be sophisticated. For with rare earth magnets only we have to construct that kind of motor, right? So that could be a bit costly also, and that could be not workable also, because at the end of the day in modern research what we are trying to do is we are trying to reduce more and more dependence on the rare earth magnets.
Okay.
Otherwise these DC motors are being used, you see these in metros and all, and they are using the
railway
DC motors only they are using.
Yeah, yes, sir. Okay, sir. Thank you.
So today, students, we have time. So from initial any session also, if you want to ask any query, you are free to ask. So we'll take the maximum queries we will take, because today's session was a little shorter. So you can ask any sort of query that you want to ask. Focus first on this session, and then from last few sessions also you can ask any query if you want. Yes, Ramesh, you want to ask anything? Yes, students, any queries like from last sessions or from this session about motors, about controllers, you can ask any query, or batteries also you want to ask, you can ask any query. Sai Kundan has asked, sir, as you said, the parts of electrical motor.
Sir, good evening, sir.
Yeah, Sai, good evening.
Sir, as you said, the parts of the electrical motor, no, sir, this all are being manufactured in India or else from the other vendor companies or from the other states?
All are manufactured in India. All could be manufactured in India except the magnet part. Okay, so magnets has to be like these rare earth magnets that we are talking about. We have to be dependent upon. We have to import those magnets. Otherwise, all can be part, because they are either like they are all casted parts, so they could be done in India only.
Okay, sir. And other question, sir, as some parts have been mentioned in a serial number or the part numbers, no, sir. This can
Yeah.
be identified, sir, for every month or from only in 6 months, sir.
Sorry, like, can you repeat your question?
Sir, as some parts are named like SRE 112 and the numbering came, no, sir.
Yeah.
This can be identified in our processor, or it can be identified in the manufacturing process only.
No, they are like, say today your motor was manufactured. Okay. So
Okay.
not only one motor was manufactured. If it is a larger unit today, maybe 1,000 or 2,000 motors must have been manufactured, right? So what
Okay, sir.
do is they will have a batch code. They will have some batch code. They will have, then they will place some months, number, date, or some serial codes they would be having. Okay. And at the end of the day, they would be placing the series number, like this motor has this series number. So that would be this motor number would be there. This would be unique to this. Okay. Then production batch number there could be there, which could be common to all the motors which have been produced today. So accordingly, every manufacturing unit follows different series code to identify the machine. Because what happens is tomorrow you can go and say claim that my motor is still in the warranty stage and it has broken down. So they can check back and they can tell us when it was manufactured, in what condition it was manufactured, right? Or if there are claims also, what happens is if there are motor is very large, there could be insurance claims also. So that these numbers and these series codes helps us in identifying the way it was manufactured and everything. It could be helpful to the manufacturer also and to the purchaser also.
Okay, sir. And one thing, sir, combustion of engine versus combustion of electrical motor. You had been told that, no, sir.
Yeah.
Sir, how can this calculation is being done, sir, as per kilowatts or kgs?
So this is like depending upon from the field data only they are doing it. So say
Okay.
when same amount of vehicle which is utilizing 1 kilowatt energy is there using. So for that, the minimum smallest amount, the volume that the engine would be taking, or the weight that the engine would be taking. So accordingly, they are experimental basis only. They have come up with these numbers.
Okay, sir.
So they have really like say 1 kilowatt load has to be driven by a engine and by a motor, and then they have calculated it.
Okay.
Sir, can you explain about windings, sir?
So windings, see, first of all, why we use windings? Normally windings, what happens is when you flow current through them, they start acting as electromagnets. Okay. So
Okay.
if we are not using permanent magnets, these windings will start acting as a magnet. So depending upon the strength of the motor, we will have number of turns also. Okay. So number of turns will be directly proportional to how much field would be generated. Okay. So according to that, and say if we want then the wiring gauge SWG, the standard wiring gauge, that depending upon the motor power, how much powerful the motor is, the standard wire gauge will also the wire will be that thicker. Okay, so all these things after taking care of, we would be winding the motor. So how many phase input is there, whether it is an AC, DC, how many coils we want to have. So depending on all those factors, we would be winding the motor.
Okay, sir. Without windings, we use magnets, sir, instead of windings.
Yeah. So say in some motors we would be using permanent magnets. Okay, there would be one magnet would be there through which you would be putting in source. Okay, where you would be connecting it, the power you would be connecting it, whether it is DC or AC, you would be connecting it. Okay, but there could be like the rotor will have winding or it will not have winding, but that will be depending upon the kind of the motor that we will be using. But in any case, these windings will be like they would be acting as an electromagnets.
Okay, sir.
Yes, guys, anyone want to ask anything like from the previous sessions also is free to ask. So one,
What
like,
is
yeah, Mohan. Yes.
what is ferromagnetic iron core, sir?
What is
Ferromagnetic iron core.
ferro?
Ferromagnet iron core, sir.
Okay, so ferromagnet iron core is the normal like core made up of iron. When magnetic field would be induced into this, it would turn into magnet.
Okay, sir.
Arvind has asked a question, sir. In the previous class, I asked you about Quark Motors or Coins Engineering company. Can you give some details of these motor? So, Arvind, what I will try to do is I will share you some information regarding this motor. Actually, I also have to research on this because I have also not gone through this. So it would be better if I share some paper with the class, Arvind, if it would be better, like if I get some research paper that I would be sharing with you. So you all guys can go through it and you could have a better understanding. And when there are like practical sessions in the Hyderabad, then you can like come up with your queries and everything. Again, one request, like when we are having these practical sessions in Hyderabad, any one of you or all of you should try that you could connect to the companies around Hyderabad and other companies where your colleagues or your friends are working. You can contact them, and if they are interested, they can like there is one session for the startups and for companies. They could join, they could attend, and where you could also interact with them and they could also interact with the student. So if anyone has any contact, so they are definitely they are very welcome to use that. So Lakhan has asked, what are the major changes made to the induction motor or hub motors to design for EVs, or it is similar to the industrial motors? So Lakhan, it is very much similar to the induction motors, only the controlling changes are being done at the controlling part. The electronics part there are some programming changes that are being done on the controller part. Otherwise, the construction of the motor, everything is the same. If you talk about the induction motors and hub motors, if you talk about, they are precisely used for electrical vehicles only. They are not used in the like any particular industrial process. They are not used. Their use is mainly for electrical two-wheelers.
Hello.
Hi, Arvind.
Hi, sir. Sir, if Tesla company enters into Indian market, can it be dominated by Indian markets like Tata, Mahindra?
Which company?
Tata or Mahindra, can they dominate Tesla company in
Tesla,
India?
see, yeah, Tesla, if you can, they can come up with a very economical vehicle. If they can come up, say, then definitely they can do it. But in India, like mostly we are very price sensitive market. So that is very, very important. Definitely they can have some audience base in form of the rich people could be attracted. But majority, if they want to increase their numbers, and they have to come with an economical car, mostly an economical car they have to come up with.
Yes, sir, that is what I am asking. If Tesla enter into Indian market, can it sustain the market from Tata and Mahindra?
If they come up with their existing models that they are selling in US,
Okay.
that won't be possible. So they have come up with some product which is specific to our Indian market. So that has to be price pointed in such a way that they could compete with Tata and Mahindra, because if you talk about present Tesla prices and Tata prices, they are close to 1/10. Okay, that is the difference between the prices. So yes, price wise, they have to come first of all to capture most of the market in electrical vehicles. They have to come up with a better pricing. Otherwise, see, if there would be audience to take that Tesla car only, there are rich people who can take buy that car as it is also. But if they want to make a major impression, they want to become a everyone's car. If they want to design, then they have to come up with a better economical car.
Also, sir, we have seen in Tata Nano car, which
Yeah,
is a failure in India, but
yeah,
because it has not reached that sales they expected.
yeah.
Can Nano EV can make the sales?
Nano EV will again be difficult, because if they come in the same avatar with the same look, if they come up with, then it would be again difficult to attract people, to be very frank, because that looks very much like a Reva car that was introduced initially. Okay, just a bigger form of Reva. And
Yes, sir.
whenever anyone is going for a car, mostly like there are a lot of feelings attached with it. Okay, you are not buying car for just for buying, like because that is
To travel.
very big asset and special asset for you when you are purchasing a car. Okay, so you think that it should look special also, because in our case, in our kind of market, if we see when we are buying a car or when we are building a house, what happens is, like, we are very emotional towards it, these things. Okay, so we can spend a bit more, but we need a better product. So the biggest failure of Nano was because of that only, because of the look wise. Just to make it economical, they have made it look like it doesn't look very much like people were not getting that feel of a car. Okay, so a
Okay.
typical model also, if they are coming up, they should change in the looks. They should change some features, they should change. Okay.
Also, sir, nowadays, if you are seeing Tata Avenue also changed its look completely
Yeah,
to the present cars. The design model of the EV cars is day by day getting into what will say like artificial intelligence type,
yeah, yeah,
AI technology type.
yeah, yeah.
How far can it sustain the market, sir? Will it attract the public, general public, like middle class families, etc.?
Yeah, middle class families, see, the biggest challenge the EVs are facing is the initial cost. That is, initial cost is very high. Okay, so for this and before some say a year or two, what was happening was there was very few finance institutions who were financing these cars. They were not financing these cars. But now what has happened is, scenario has changed. More and more banks are financing these cars, so scenario is changing. Okay, but this price point, that the initial cost, that until and that is brought say 20% down. So government has given some subsidy, due to which initial cost has come a bit of a bit down. It has come, but then also it has to come again by another 20%. The initial cost has to come down before it starts being attracted by a general public. So cost, as I said, in Indian market, cost is like, we are very price sensitive market. As I said, the initial cost plays a very huge factor. We can make our car intelligent. We can add lot of features into the car, but beforehand, major attracting point would be the initial cost.
Okay.
Because you see why Maruti was so popular in India. The major point was because of this only, because the Hero Splendor caught lot of market because of that. So price very, very important in our market.
So that is what I'm asking, sir. EV
Yeah.
design is completely different nowadays, right?
Yeah,
We are focusing on software side, then the beautiful, what is it? Beautiful looks. If you see the pics of Avanya of Tata, completely different from Tata Nexon,
yeah,
which is also another EV. So
yeah.
that's why I'm asking. Design changes in the EV cars, how can it be increase the sales, attract the people?
it can attract the people, but as I again said that pricing will play a major role. If we talk about Indian market, the pricing will play a big role, because we tend to, and if financing structure becomes much smoother, then and with proper pricing, yes, they can attract a bigger market.
Okay, sir.
And with increasing oil prices, because everyone now knows that operating cost of a normal vehicle is much higher when you compare it with an electrical vehicle. So that concept has come into the mindset of the people, but still the initial cost is something that people don't want to pay. That is why major cause of EV not becoming very famous. Now two-wheelers are becoming famous, three-wheelers are becoming very popular. Why? Because their initial cost is very much comparative to their ICE counterparts. That is why their sales have increased multifold times, you could see. But in four, still the sales are not able to increase in comparative to the IC, because of these drawbacks. And second is also definitely, yes, charging infrastructure also plays a major role when anyone is buying a car. So he looks into that thing also.
Okay, sir. Okay. Thank you, sir.
Guys, anyone has any query? Anyone want to ask anything? He can, he can either post in the chat box or he can raise his hand. So Renuka, I think students have asked their query, and now there is no one coming up to ask any further query. So maybe we can close the session for today.
Sir, yes, sir. And before closing the session, okay, so we will going to inform for all people, okay. So, sir, can you inform them, sir? It's better.
Regarding?
Yeah, regarding for the presentation, sir, in offline training part, we already
Okay.
having schedule, sir, regarding for the presentation part.
Okay. So you either you can share in the group, or you can inform them. So what has been decided, students, is when we are going for the offline session. So here we have we had 17 session that we have covered in our online session. So for better understanding, we have given one viewpoint to each and every topic. Now what we want is your viewpoint on those topics. One is we have made groups, and we have to each and every group we have given some topics which we have already covered during our online session. So you have to prepare information, you have to prepare presentation on these topics, so you we can judge how much you have understood, or you can have understanding in the depth. So groups will be informed. Renuka, you will be informing them about the groups, right, and the topics that each one have to.
Sir, I didn't share, sir. Okay, so after complete this session, I'm just going to share.
Definitely. So the idea, I think students' idea is clear to you. So all these 17 sessions that we are covering in the online sessions, that would be distributed like two or three session to every group, and you all have to prepare presentation on them, and or the research paper you have to present, and you have to present during your offline session. So so that we can see how much you have understood, or you could have you can research further, and you could have a better understanding of the topics.
Yes, sir. So students, for all people, okay. So after completed session, I'm just going to share one of Excel format. Okay, it's kindly once again go through on it. Okay, so every group, for every group, I'm just given the 2 sessions. Kindly once check out. If you're having any doubts, we will discuss tomorrow.
You can like see into this, see into that. The groups are formed. The topic is allotted to you. You go through them, and if you have any query, if you want to ask any query, tomorrow we can discuss on those.
Hello, sir.
Yes, Arvind.
Sir, this is not about the theory classes that are done. Sir, can we have a change in the timetable for tomorrow? Either to the morning or afternoon session, why? Because tomorrow is Ganesh Nimajanam, right, sir?
This I think like Renuka, how we do this.
Yes, I just want to discuss to our course delivering department. After that, I will confirm.
So like this Renuka would be informing you guys if but I think there won't be like any
Yes, if possible, okay, for all people, okay, kindly like give response. So how many like of students need in morning session? So because I'm also staying in Hyderabad, I know how like of Ganesh Nimajanam is happening in
so
Hyderabad.
this okay, so this is a big festival.
Not only, ma'am, not only for attending Ganesh Nimajanam, but also if we stay in the home, also we get very noise pollution, heavy noise pollution. So we cannot concentrate or listen to classes properly. So that's why we need afternoon or morning sessions.
Yes, yes. How many students need? Kindly post in the chat box. At the based on I can discuss our like of my like of course delivering department. Guys, give response.
So
Okay.
okay, if you're okay with this timing only, or you want a change in the schedule. Okay, so write change if you want change in the schedule, or if you are okay with current schedule, then write okay.
Okay. Yes, sir. Definitely. I just wants to talk to our like a post delivering department. After that, I will confirm in the like a I will confirm in
Okay,
the
you can check back, and then you can discuss with the students, and also you have to discuss with Sujoy sir and Nabhangshu sir also, because they would also
yes.
present. Okay, because tomorrow is I think the closing sessions we have tomorrow. The last two sessions tomorrow we have, so it has to be coordinated well with everyone before we.
Yes, yes, sir. Yes, that's a problem. Yes,
Okay,
sir.
Renuka, you take care of that. And, okay, students. So for today we close the session, and
Yes.
tomorrow back.
Yes, sir. Today we'll just close the session and thank you, Govind sir. Thank you for all people. Okay, for happy weekend, and we'll discuss. Okay, so students, don't worry. We will just once to confirm our post delivery department. After that, I will confirm the timings. Okay.
Okay, thank you, Renuka, and thank you all the students. Thank you, and tomorrow we meet again, and Renuka will confirm you on the timing, like whether it would be a morning session or an evening session. Thank you, everyone. Thank you.